some of the questions today are going to give you a graph, and they're going to say, determine the degree of the graph. Okay, so how do I figure that out from a graph? I'm just going to kind of sketch something. So, I don't know. I just kind of sketching a little bit of a graph. Now, automatically, do you guys know if that's odd or even, what I just sketched? Odd, because the ends go opposite directions. I immediately know that's odd. Now, to go for the lowest degree possible, this is, I don't know how to describe this to you other than it's the number of different directions you go on the graph. So, like, if I go up here, I'm basically like increasing, decreasing, if you guys remember doing that with our quadratics. So, increasing, then I'm decreasing. Then I'm increasing, then I'm decreasing, and then I am increasing again. So every different color would basically count as a degree. So here'd be 1, 2, 3, 4, 5. So the lowest degree on this is what I sketched would be a 5th degree. So it's the number of intervals you have that are different, increasing and decreasing is the best way I could describe that. I immediately know that guy is odd because the end behavior goes opposite directions. If it's even, the end behavior will go the same direction. Okay, so, and this is the lowest possible. So you could have imaginary answers that maybe don't cross the x-axis or something like that. So that's why that says it's the lowest possible degree. I know it has to be odd, but there is a possibility if we had a bounce or something like that, maybe it's a 7th degree or maybe it's a 9th degree or something like that. But the lowest possible degree is what you're going to be asked to determine. So if I look at this guy right here, it doesn't ask you for the degree, but I'm just going to ask you, can you tell if this graph is even or odd? This has to be odd because we go opposite directions. Okay, now, if you're trying to figure out the lowest possible degree, like I said, it's just the number of different intervals of increasing, decreasing. So like increasing, then I turn, then I'm decreasing, and then I'm increasing. So what's the lowest possible degree there? 3. Lowest possible, this would be a 3rd. So lowest possible, this has to be like x to the 3rd or cubic or whatever you're going to say. I'm just going to say 3rd or 3. All right, what do you guys think for the graph next to this, even or odd? Even. Okay, let me also ask you, is the leading coefficient positive or negative? Negative. Good. This has to be even and negative. Let me back up to this one. Is this one positive or negative? These are trickier when they're odd. Is it positive or negative? Positive, yep. If it's odd, whatever it does at the end of the graph, so if it's going up at the end of the graph, then it's positive. If it's even, that works the same way. Whatever it's doing on the far right, that'll tell you whether it's positive or negative. If it's going up, it's positive. If it's going down, it's negative. Whatever's going on the far right. Anywho, okay, can anybody tell me what's the lowest possible degree of this graph? 4. Yeah, this is a 4, right? I'm going increasing, decreasing. There's a little bounce here, increasing, decreasing. That was not in different colors, so that was not easy to see what I was doing there. Let me color these. So then you got 4 different increasing, decreasing. It's minimum 4th degree. Okay. Now, I'm just doing this with several different graphs. Okay, so is the leading coefficient on this next graph, what do you think, positive or negative? It has to be positive. And I promise, whatever it's doing on the far right, if it's going up on the far right, it's positive. If it's going down on the far right, then it's going to be a negative leading coefficient. What would you guys tell me the lowest possible degree is for this graph? So like if I'm coloring on it, Eli, what do you think? This is 4th. And I should be better with my markers, but you've got, this is decreasing, this is decreasing. So 1, 2, these are both increasing, 3, 4. So you got 4 different intervals of increasing or decreasing, so it's a 4th degree. Okay, can you tell me, just raise your hand, from the graph, what are the zeros of this polynomial? Carter, go ahead. -4, -1, yep. 3 and 6, perfect. Okay, do I have any multiplicities here that are even? on this graph? Like, do we have any bounces on this graph? No. Okay. So when I ask you guys down here, and again, I don't have the y-axis labeled at all. So what I'm going to write down here is just a possible version of the factored form of this. Basically, I'm going to see if I can take the zeros and transfer those into linear factors from the graph for this bottom part. So, and they don't have to come in a particular order, but let's just write them in the order we wrote the zeros. If I did -4 as a 0, how would you tell me a little set of parentheses for the factored form? If -4 is your 0, what's the little linear factor that would go with that? Exactly. Okay, x plus 4. What about -1? What would be the linear factor that would go with that? X plus 1. Now, what if it's +3? X minus 3. There you go. So if it's a +0, when you write it in the little linear factor, and I keep calling it a linear factor, you just have an x. The highest power there, x, if you remember the names we had for those the other day, linear. So these are linear factors, what that's called, because it just has an x. And then we'd also have x minus 6. Okay, now this is positive. If it was negative, I would maybe need to add a little negative in front of my factored form, but that could be a possible equation for that graph. And we're just going to write factored form. We're not going to multiply it out or anything like that. So let me have you guys look at this one. Is the leading coefficient here positive or negative? What do you think? Positive or negative? It got to be negative, right? All right, now my lowest possible degree here, I am like increasing in a couple spots here, and I'm decreasing in a couple spots. So what is my lowest possible degree going to be here? 4, right? We got 1, 2, 3, 4. That's the number of intervals we would have there. Okay, what are my zeros for this graph? Go ahead. -3, 1, and 5. Okay, do we have any bounces on this graph? We do. Okay, so keep that in mind. So right here at the 1, I have a bounce. Okay, now when you write the factored form then, which we're going to do here in a second, all you're going to do is, with that little set of parentheses, you just got to give it an even exponent to show that it's a bounce. And it could be, I usually just use 2, but you could use 4, you could use 6, you could use whatever you want. But we got to make sure that when I write that linear factor that we've got an exponent on it. Okay, now the other thing I want to make sure I have you guys put. Do you guys see how you told me the leading coefficient has to be negative here? This is always the one that screws people up. Okay, you have got to put just like a little negative out in front of these factors if you're going to write this. So I'm just going to put a little negative out in front. All right, now the zeros, I've got -3, so x plus 3. I've got +1, so it'd be x minus 1. And then I've got 5, so it would be x minus 5. And again, those don't have to come in any particular order. I just listed them how we listed them across the x-axis. The only other thing you got to do there, if you have a bounce, which we have a bounce on the 1, you just have to make sure that that little factor has an even exponent. You can use any even number you want. Like I said, I usually just use a 2. So if you see a bounce, you got to show me that that's got an even exponent. Any even number you want to use, I usually just use 2. Is anybody having a question? Okay. I got 2 more on the back and that's it. All right. So, you guys think, is the leading coefficient here positive or negative? Has to be positive. Whatever it's doing on the far right of the graph, so this one's going up. If it's positive, whatever it's doing on the far right, that'll be up is positive, down is negative. So this will be positive. What's my degree, my lowest possible degree here? 3. All right, now let's see what our zeros are. It looks like -5, 0, and 2. All right, no bounces here. If 0 is one of your zeros, how do you represent that? X. Now, it doesn't really matter, but typically if 0 is one of the zeros, you're just going to start your factored form out with that X. So I'm going to put that first. And then my other 2 factors Honestly, it doesn't really matter the order at all, but I usually put, if I've got just an x, it doesn't have a set of parentheses, I'll put that out in front. And then -5 would be x plus 5, and 2 would be x minus 2. We said that this was positive, so I don't need to add a little negative in front. No bounces, don't need to add any exponents, so we should be good to go on that one. All right, now this last one, what do we think? Is the leading coefficient positive or negative? Negative. Whatever it's doing on the far right, this is pointed down. This is negative. Now these guys both here on the back, these are both odd. The two we did on the front are both even. Odd, the end behavior is going to point opposite directions. Even, they're both going to point the same direction. Probably should have asked you that, but I didn't. Okay, now, this one's a lot. So let's see. I'm just going to trace how many decreasing intervals I have here. And then I'm going to go back with a different color to trace all my increasing intervals, so you guys can see that. What is the lowest possible degree on this one? 5. So I've got like 1, 2, 3, 4, 5 different intervals of increasing or decreasing. What are my zeros for this graph? -4 is 1. -1, 4, 6. Okay, do I have any bounces? At what number? -1. Okay, so all the other ones go through the x-axis. Okay, so I have a bounce at -1. So when you write this, first of all, I'm going to start out, because I said this was negative, so I'm just going to put a little negative out in front. And then it doesn't matter the order that you want to put the zeros in, just however you want to write it. I'm just going to write them how I wrote them. So I'm going to write x plus 4 for the -4, x plus 1 for the -1, x minus 4, and I should have left some more room or written smaller, x minus 6. Now, I do have to go back. If you have a bounce, you just need an even exponent on that number. So the -1 has a bounce. So I'm just going to put a squared. You could put any even number that you want. It doesn't have to be 2. I usually just use 2. But we're just kind of doing a basic representation of the graph in factor form.